Hi, I'm Aleksandra and I'm a digital artist. In this tutorial, we will explore how splines are built with a new set of functions in p5.js 2. We will go over the first steps in drawing smoother, more natural lines. Along the way, I'll share a few tricks and a bit of the math I use to shape curves. When you first start with p5.js, you usually begin with simple geometries. But after a while, straight lines and perfect circles can feel a bit boring, and you start looking for ways to make forms that feel more fluid and organic. In math, curves are described by using polynomial functions. There are many types, but in p5.js you'll find two: Bezier curves and Catmull-Rom curves. Bezier curves let you define any shape imaginable, but they can also be a bit more complex to work with. On the other hand, Catmull-Rom curves are easier to grasp and quicker to build, so that's what we'll focus on in this tutorial. When we use term splines, we are referring to a series of curves connected together into one continuous line. Instead of separate segments, they look as a single flowing shape. A simple way to picture this is like bending a cable smoothly around a set of pins. Each segment of the spline is defined by 2 points, beginning and ending, but also by the points just before and after. Those neighboring points influence how the curve bends as it passes through. Now, let's move into the code. In p5.js editor, we will choose any version above 2.0 because these versions support new spline functions. First, we will make an array to store some coordinates in it. Let's say 10 points, and that will be random points in an array. Then, in the draw, we can loop through them and draw a polygon shape by connecting each point in order. Adding close as an argument to end shape, it will also connect the last point to the first one, turning the line into a closed shape. Now comes the cool part. We can simply replace vertex with splineVertex, and the polygon instantly turns into a smooth, continuous curve. So, with just one small change, we move from a low poly shape to something much more fluid, but we can push it further. For each Catmull-Rom segment, the curve usually depends on 4 points. The inner points define where the line passes, while the outer ones influence how it bends. This is the default. splineProperty, ends, include, and before and after segments are included in the curve. You would use exclude to leave them out. There is also the question of how much the curve bends. That's controlled by splineProperty tightness. You can think of it as adjusting how strongly the curve pulls between points. At 0, you get the default Catmull-Rom behavior. At 1, the curve straightens into lines. This function also accepts higher and lower values, so check out how the curve behaves with other values. In generative art, we often search for balance between chaos and order. So instead of placing points completely at random, we can arrange them into different shapes using some trigonometry or math functions. For example, we can place points along a circle. We can flatten a circle. Form a 4-pointed star. A shape with few or many petals. Or we can mix circle with a bit of randomness. For example, let's place points around a circle but vary the distance from the center. Each point gets a new position after reload. A step further would be to replace random with noise, and then we get smooth animations of an almost organic blobby shape. From here, we can explore a few variations. Let's remove the decorations and restyle the blob a bit. While we are at it, let's also separate recalculating noise positions from the actual drawing of the shape. Now we can stop clearing the background, and the previous frames stay visible on the canvas. We can also add a little bit of global movement to make things just a little bit more interesting. Now, if we draw the same blob twice and make the top one with a slightly thinner stroke weight, we can get an outline effect. Adding a third copy can give us a simple shadow. And one of my favorite tricks is stacking copies slightly offset and in a darker shade. And we fit the translation values just a bit until the form starts to feel dimensional. It's not truly 3D, but it creates that illusion. In the final step, I've converted construction of rubber bands into a class and then generated many instances in the setup, and also added a function for adding new ones on a click. Each rubber band has a different shape, different movement, and different color. If this got you interested in drawing with splines, there are two more really useful functions you can explore. What if you want to place something anywhere on a curve segment? Or have it just touch the curve, stay perpendicular to it, or keep a consistent distance as it moves along the curve? That's where splinePoint and splineTangent come in. SplinePoint lets you find an exact position along a curve segment. We pass a value between 0 and 1 as last argument, where 0 is the start of the segment and 1 is the end. And the function returns the coordinates for the point on the curve at that chosen position. splineTangent works in a similar way. It gives us the tangent at chosen position on a spline. Once we have that, we can calculate the angle, rotate it to get a normal, or position something around the curve. I hope this gives you a starting point to explore your own variations and to see where using splines can take your drawings. Thanks for watching and happy coding!